Hello, I'm David Greenwood from Newcastle University in the UK. And on behalf of all the authors listed here, I'm going to be presenting paper number 64, which is Local Distribution Network Management through Optimal Flexibility Scheduling, the Austrian pilot site of the Horizon 2020 Merlon project. So this is an overview of the contents of the presentation. So first of all, I'm going to give an overview of what the project is. I'm going to talk about the pilot site. I'm going to talk about the solution that we're developing for Merlon and different components of that. I'm going to look at a specific case study, which is the scheduling of flexible energy resources within the Austrian pilot site. I'm going to talk about how we can replicate the solution, which has been designed for a European context in an Indian context. And then I'm going to talk about the next steps and conclusions from the project. So Merlon is a smart local energy system project. It brings together 13 different partners from 6 different countries. And the aim of the project is to develop novel tools and business models for integrated local energy systems. And as part of the project, we are developing a number of different tools, and then we're going to demonstrate them at 2 different pilot sites, one in Austria, which we're going to talk about today, and the second, which is in the south of Spain. So the Austrian pilot site is the village of Strem, which is in the Gussing area of Austria, which is in the eastern end of Austria. The village of Strem is at the end of a long transmission line within their distribution network, which is at 20 kV. And it has a very large amount of renewable generation that's been installed and a relatively small number of customers. It's only a few hundred people live in Strem. And the power line that connects Strem to the rest of the energy Gussing network is effectively going to limit them from being able to install any more renewable energy here. So this figure here shows the amount of power that we are either exporting or importing from the Strem area. What we can see here is that there are very few periods where this Strem village imports power from the wider distribution system, and the majority of the time it's actually exporting. And this is a bit of a problem because in the Strem site, one in all of Austria actually, the distribution network has to run within very tight bounds. So the voltage on the distribution network is only had to be plus or minus 2% of the nominal value. What we see here is that quite often this is going to be in breach of that, and that's because we've got very high levels of local generation. So we're going to end up with high voltages. And that means that we're going to need to do something to deal with these voltages if we want to accommodate any more photovoltaics. So the Merlon solution allows us to do that. But what's novel about it is that it's doing it in both terms of business models and a technical solution. So the business model of the Merlon project aims to allow us to manage the local network using flexibility and increase the hosting capacity for renewable generation. But we're going to do that by incentivizing local flexibility to solve any problems with the system. Once we've solved the existing problems, we can then increase the energy yield and the amount of hosting capacity we have for renewable generation. We can also allow prosumers within the local network to trade either energy or flexibility to each other, and we can allow them to act together as a virtual power plant and sell either energy or system services to the wider transmission or distribution network. In terms of how this works as a technical solution, we have different layers. So the main kind of layer that sees everything that's going on is this integrated local energy system management. Then the next layer is we have the inputs to the ILESEM, which is a global flexibility manager, which takes together a number of different prosumers. We have a battery management module. So one of the things we've done during the project is install a large-scale battery system at both of the pilot sites, and we've got a bespoke set of kind of Merlon battery management module which controls this, and then information from the photovoltaic plants. And then one layer deeper than that, we have what we're calling local flexibility managers, and these are installed on the sites of individual prosumers. So the examples we have here are building flexibility managers and electric vehicle flexibility managers. This slide is just going to go into the different technical components in a bit more detail. So the first thing is these are the local flexibility managers. So the building flexibility manager allows us to turn the buildings into virtual thermal energy storage, and that allows us to provide flexibility. And then the EV flexibility module does a similar thing with electric vehicles. So We enable electric vehicles to act as both demand assets and energy storage assets. And we do that in a way that we're minimizing disruption to people's kind of driving experiences from the electric vehicles. These all feed into a global flexibility manager. And what that does is it takes the flexibility from these individual prosumers and it aggregates it at different nodes within the distribution system. And it then sends signals out to dispatch flexibility at each of those nodes as they're required to assist the distribution system or fulfill services to the wider transmission system. Next, at a higher level than that, we have the forecasting module, which assesses how much demand and generation there's going to be through continuous monitoring of the demand and generation at each of the nodes in the network and running artificial intelligence forecasts at each node in the network, and then allow us to aggregate that up to a forecast for the whole of the STREM site. And the instance aggregation module, which is a holistic platform and manages the operation of everything within the integrated local energy system. And finally, we have the integrated battery energy storage system management module. So there's a large scale battery system installed at both the pilot sites. And this manages that in terms of its state of charge, in terms of real and reactive power set points that are issued to it, in terms of setting it into the mode to fulfill different kind of transmission system services, for example, frequency response. And if there's an emergency situation, to switch the system into islanding mode. The module I haven't discussed there is the scheduling module, and we're going to talk about that a bit more in a case study. What this does is it takes inputs from the battery energy management module and the the global flexibility manager via the local flexibility managers and the forecasting module, and it turns that into a schedule of what the best way to use all the assets on the system is. It has built into it a model of the local network. It takes in electricity price. It takes in the price of using the different flexible assets as calculated by the global flexibility manager. And it schedules the system to make sure that we're meeting all the constraints and then to reduce the cost of operating the system. And so the kind of the outputs it will give us is, what should the battery energy storage system do? Should it charge or discharge? What should it do with its reactive power? And what should the different flexible assets do? Do we need them to increase their consumption? Do we need them to decrease their consumption? And what we can see here is by running the scheduling process, we go from the first picture where some of the buses we're going to exceed our voltage limit, to the second picture where everything is operating within but to the limits of the system. And then what we can see at the bottom is the schedule that's been sent to the battery system to do this, in terms of charging the battery in terms of its real power, and also here you can see we're discharging it at points in terms of its reactive power. It's good to know that when we run this scheduling process, we do two things. One is that we resolve the constraints we had, and the second is that we reduce the cost to operate the system overall. And we do that by rewarding customers for providing helpful behavior. So it's a system that is kind of providing benefits both in terms of technical and economic goals, and it's doing it for both the system operator and for the customers within the system. We've developed the system, as I say, in a European context, but part of the aim of the project is to allow it to be replicated in other countries, and specifically India. So we have, as part of the consortium, an Indian partner called NZEN, who provide us with kind of review and information about what we can do to make this solution work in an Indian context. So there are a number of similarities where this can help. So one is ambitious plans for the uptake of renewable energy and electrified transport, the need for flexibility to integrate low carbon technologies, and that in India there are a large number of DSOs with different business models and ownership models, and that's true in the European context as well. One big difference is that renewable energy in India is primarily large-scale projects connected at transmission level, as opposed to small-scale projects connected at distribution level. The idea of using the integrated local energy systems to kind of absorb excess generation and reduce the cost of building the infrastructure to connect large renewable energy resources currently probably wouldn't work in terms of the regulations in the Indian context, even if it would work in terms of the technical solution. And then there are some rural communities with significant renewable resources but weak grid connections, and some of these have kind of unique resources like these solar irrigation systems, which would be something different to integrate and kind of operate within the Merlon framework. So conclusions and next steps. So the main conclusion is the Merlon solution can solve problems on local distribution networks while reducing local energy costs and increasing the use of local renewable energy. It's a modular generalizable set of tools for integrated local energy systems, and it's been designed for EU networks, but has applications in other contexts, including India. And then in terms of the next steps, well, we're going for full-scale integrated demonstration of both pilot sites. Okay, thank you very much. I'm happy to take any questions.